So we studied about this equation, V upon I is equal to R, which we better known as Ohm's law. After we studied resistance, we came across a term called resistivity. Now, what is resistivity? Resistivity is also talking about resistance, but it is resistance per meter of a standard wire. So what is the importance of resistivity? Resistivity helps me choose a material, whichever I am choosing, either as my conductor or I am choosing it as my insulator. So start thinking about yourself. When you choose about a conductor, what type of material should be your conductor? Something whose resistance is very less. A conductor is someone who should not offer any resistance. And suppose if I am talking about an insulator, I should talk about a substance or a material whose resistivity is infinite, right? So how do you select that material? That material can be selected based on a property, inherent property of that material called resistivity. So resistivity is a property which is unique to every element. Based on that property, we can actually choose whether we want to make a conductor out of it, we do not want to make a conductor out of it, or say suppose we have got a commercial limitations, we can't go on cost, we can lower down our cost. Everything depends upon this inherent property called resistivity. Now when we talk about resistivity, it is specific to a particular element. Like silver has got a resistivity, copper has got a resistivity, वो change नहीं होता है, but you can make different specs of copper wire. Specs means different diameter, different length. Each of those wires will have different resistivity. So let me draw a diagram and just try to make you understand. Say suppose 1 minute. This piece of, just a minute, children. Why is the ink not flowing through? Suddenly the ink is not flowing through. I just filled ink. No. Okay. Say suppose I have a piece of copper out here. Okay. Let's say this is a piece of copper. The resistivity of this piece is fixed. Resistivity is fixed. Or if I have a strand of wire, I don't know what is the dimension. Iska bhi resistivity fixed and both are same. Please understand. Both are same. However, from this, I have made two type of wires. One is this much length and this much is the dimension. And one is something like this and this much is the dimension. These all will have different resistivity, R1, R2. Iska resistance, sorry, different resistivity, nahi, resistance. Iska resistance hoga R3. None of them will be equal to each other. None of them will be equal to each other. But their inherent resistivity is same. Resistivity is material specific. So how did we get into the term resistivity? We said resistance is directly proportional to length. Resistance is inversely proportional to area. Combining both, we say resistance is directly proportional to length over area, or resistance is equal to some constant. We have to bring a constant out here and then do it L upon A. That constant is known as resistivity. So how do you write resistivity? If you actually make this ratio as 1, so how do you make this ratio 1? Resistance is always measured in ohm. Resistivity, I keep it like that because I want to find out what is its unit. Length is measured in meter, area is in meter square, but we have made it, the ratio is 1. So ultimately meter square. So meter strikes out 2. So this becomes rho, and here the unit is meter. Meter goes this side. So resistance is equal to resistivity in terms of ohm meter. And this is what this tells you about the unit of resistivity. And how do you define? Resistivity is the resistance of a conductor of the same material, which is 1 unit in length and 1 unit in cross-sectional area. Take a piece of copper and make a wire of copper which is 1 meter long and make its cross-sectional area. Cross-sectional area, that is pi d square by 4 or pi r square by 2 equal to 1. Then the resistance that copper will offer. अब समझ में आ रहा है क्या है? कॉपर का एक वायर लो, ऐसा वायर जिसका लेंथ कितना होना चाहिए बेटा? 1 मीटर, and the cross sectional area should be 1 meter square, means not diameter, 1 meter square is pi d square by 4. Pi d square by 4 is the formula for area. I hope you understand this. Pi r square by 2 is same as pi d square by 4. This value should be 1 and length is 1. Then this conductor can be compared to give some sort of a resistance. This also becomes a resistance. Whatever is the resistance at this time with this particular dimension, that is the resistivity of copper. That is how we define it. What is resistivity? Resistivity is the resistivity of a material, resistivity of copper, resistivity of silver, resistivity of gold is the resistance of a wire made of gold whose length should be 1 meter and cross-sectional area 1 meter square. Comes from this formula. Rho can be made to equal to R only when you make L upon A as 1. L upon A is 1 means L को भी 1 करो, A को भी 1 करो. और याद रहे L will be 1 meter, A will be 1 meter square. Means ऐसा एक वायर बनाओ जिसकी लंबाई हो 1 मीटर, क्रॉस सेक्शनल एरिया हो 1 मीटर स्क्वायर. जिस मटेरियल से बना रहे हो उस मटेरियल की रेजिस्टिविटी इस टिपिकल वायर का रेजिस्टेंस होगा. Understood? So once you get to know the value of resistivity of different materials, then you can choose whom you should pick to be your good conductor, whom you should pick to be your good insulator. If you want to pick up, say, glass resistivity, by birth glass will have very high resistivity. So it's an ideal choice to make insulators out of glass. That's why screwdriver handles are made of glass se bana sakte hain. And if you look at, say, something like aluminum, resistivity is very low. By birth, it has got conductor property. So you can make a good wire out of it. Between again aluminum and silver, you will see silver's resistivity is even low. So we can have even better wires. मतलब और छोटे-छोटे wires में वो काम हो जाएगा. लेकिन महंगा भी होगा. Cost will also go up. Resistive. All non-metals, carbons, yes, not carbon. We can have resistive means like gases are there. Generally हम इनमें non-metal से बनाते हैं तो इसमें माइका है. माइका की resistivity काफी high है. Element करके नहीं बोलते. माइका substances. ठीक है. Now from here you will get some sort of tricky questions. Let's see what are the tricky questions that we get from here. And after that we'll spend some time on real life examples also. ऐसे किताबी ज्ञान पढ़ के कुछ नहीं होने वाला है. आओ. So see what are the tricky questions we can get from here. Let's say मेरे पास एक वायर है. The cross sectional area of this wire is A. ठीक है. That means its original diameter of this wire, diameter को हम engineering में phi से लिखते हैं. Phi is equal to D. D is the diameter of this wire. ठीक है. This is how in engineering you show the diameter. Phi, phi. So this is how you show diameter, the measurement of diameter. In high-end engineering drawings, radius is shown like this, and then you put like this. Phi 2r means twice of r is the radius. Okay, so phi d is the diameter of this wire. Okay, and the length of this wire is say L. कितना है बच्चा? L. All of you understand this? Okay, L. But the cross-sectional area is A. Means A का formula क्या होगा? A's formula will be pi d square by 4. Is this understood? Pi d square by 4 gives me A. A is the cross-section. That's what we are interested in. D से उतना interest नहीं है. आ जाओ. So we calculate the resistance of this particular wire. Now we got a new formula for resistance. Not only V by I. We'll do a lot of problems today with V by I and this. So the resistance is given by rho L upon A. Agreed? Rho L upon A is the resistance of this wire. We don't know what is the L. ठीक है? ये हमने बनाया. Now what our friend Shaurya does, what he does, he keeps the dimension same, that is the cross section same, और वो इसको double length बना देता है. Shaurya has now kept the diameter same. Okay, the diameter still standing at phi equal to d, so the cross sectional area is still A, but what he has done, he has increased the length to how much? 12. तो ये हमारा सिनारियो 1 है बेटा, और ये सिनारियो 2 है. तो R1 में कितना आया हमें? R1 में हमारा आया L upon A, राइट? अब हम R2 का रेजिस्टेंस देखते हैं. R2 में did the material change? No. तो रेजिस्टिविटी तो वही रहेगा. What happened to the length? 2L हो गया. And what is the मोटापा? Same. So A is same. ठीक है. अब हम क्या करते हैं, R1 अपॉन R2 करने की कोशिश करते हैं, R1 अपॉन R2. सो रो L अपॉन A डिवाइडेड बाय रो 2L अपॉन A. ओके, सो विच कैन बी रिटन एज, इसको इसी तरह लिखे तो ऐसे लिखें, रो L by A is divided by another row L by A. So A by row 2L, ऐसे लिख लें. Same, row L by A, row L by 2A. Row cancels row, A cancels A, L cancels L, sorry, row cancels row, L cancels L, this. So you get a ratio of 1 upon 2. That means R1 will be equal to, 2 of R1 is equal to R2. Means if you have increased the length, the new resistance gets doubled of the previous one. Very big finding. इसके पर बहुत questions आ जाते हैं. So if the conclusion is, if length is doubled, if length is doubled and provided A is kept constant, A is constant, then R is also doubled. ये जरा लिख लीजिए तो, तब तक मैं एक पेन लेके आता हूं. If length is doubled and provided A is kept constant, मतलब उसी साइज मोटा वायर रखो, your resistance get doubled. So now just think about yourself. If your headphone wires are made twice the length as they are originally by the manufacturer, the resistance will get doubled and your audio quality will distort. Are you able to understand the implication of this? We have a standard length of headphone wire. So don't change the thickness of the headphone wire, but just increase the length of the headphone wire. Then the audio quality is bound to drop. So you children today nowadays have Bluetooth headphones, but say suppose let's go 8 years back when Bluetooth was not that of a very big technology, and you want to listen to the TV lying on the bed. So what do? You take your headphones, and in the market extender wires are available. You can just couple those sockets and you can put it. So you think you are able to hear, but you're not hearing the noise, not noise, the melody as you used to hear it when only the standard length was there. हाँ, तो वॉल्यूम में डिस्टॉर्शन तो आएगा, आपके कान उसको नहीं सुन पा रहे हैं, पर डिस्टॉर्शन है. समझ में आया? ठीक है, ये वाला क्राइटेरिया क्लियर है. इफ यू आर डबलिंग द लेंथ, ये रिमेंबर रखना, इसके बहुत क्वेश्चन आते हैं फ्रेंड्स ऑफ लेंथ्स में. इफ लेंथ इज डबल विथ एरिया केप्ट कांस्टेंट, then what happens? Resistance gets doubled. Pakka? Can I rub this now? We'll see another scenario. Can we done? Yeah, sure. अच्छे से इसको समझिए. लेंथ सेम है, सही, लेंथ डबल हो गया है, एरिया सेम रखा है. Done? All of you done? Can I rub this? थोड़ा और इसमें let's see some more iterations on this. Okay, so पहला वाला डायग्राम वैसे ही रहने दीजिए, दूसरे वाले में थोड़ा और मस्ती करते हैं. Now scenario 1, what did we find the resistance in scenario 1? R1 is equal to rho L upon A. This is what we found. Agreed? Now what we do, we now keep the length same and no, we will reduce the dia. अच्छा, ठीक है. So we'll keep the length same and we have reduced the dia. ठीक है. Now the new dia that I have, the new dia phi is equal to d by 2. हाफ कर दिया इसके डायमीटर को. लेंथ को कितना रखा बेटा? लेंथ को L ही रखा. लेंथ इज केप्ट एज L. और तो इसका एरिया कितना होगा जरा देखो तो. दिस इज A1 नाउ. A2 कितना हो जाएगा? Pi, it will be d by 2 square by 4. New diameter is half of that, right? So इसको करेंगे तो कितना आएगा? Pi d square by 4 divided by another 4. Pi d square by 4 divided by another 4. Can I not write it as 1/4 A1 लिख सकता हूं इसको? ये चीज समझ में आया? I can write it as 1/4 of A1. That means if you have the dia the cross section falls down by a factor of 1/4. प्लीज यही गड़बड़ी कर देता है, लेंथ को डबल करने से डबल, अभी रेजिस्टिविटी पे नहीं आए, पर अभी एरिया पे क्या होता है, इफ यू half the diameter, the cross sectional area falls to 1/4 of the original area. Look at the diameter of this marker pen, it has some area. Now you say that, sir, a new diameter marker pen is available which is exactly half the diameter of your marker pen. Then what is its cross sectional area? 1/4 of this. हमने proof किया ना, 1/4 of this. So let's write down what should be your R2 now equal to rho L remains the same and it becomes how much? तो A1 लिखने की जरूरत नहीं, A1 ही लिखते हैं, इसको भी A ही रख देते हैं, तो इसको कितना लिखेंगे? A/4 L/A. In its case A is this much. पक्का बच्चा, समझ में आया? तो इसको कैसे लिखेंगे? Rho L divided by A/4 means 4/A. So I can write it as 4 rho L by A. A लिख सकते हैं, ठीक है? अब जरा R1 by R2 करके देखते हैं. R1 by R2 is rho L by A into A by how much? 4 rho L. ठीक है? So rho cancels rho, L cancels L, A cancels A. So you find R1, 4 times of R1 is equal to R2. So if length is increased, resistance increases, the new resistance becomes twice. ठीक है? And here if you are making it half the thickness is reduced to half, then the resistivity, new resistivity goes up by 4 times. So question arises, if I have a thick wire and if I have a thin wire, which offers more resistance? अब आप खुद ही देख लो, ये क्या है? Thin wire, ये क्या है? Thick wire. बोलो किस वायर में रेजिस्टेंस ज्यादा है? थिन वायर का कितना है? 4 times of. थिन वायर हैज मोर रेजिस्टेंस, थिन वायर हैज मोर रेजिस्टेंस. अब जरा सोचो, माइक्रोवेव, टोस्टर, गीजर, एसी, इन सब के वायर्स पतले होते हैं कि मोटे होते हैं? मोटे मोटे होते हैं, मोटे मोटे होते हैं, क्योंकि उनका रेजिस्टेंस कम होना चाहिए. AC and all are like bullet, they just eat electricity. करके इलेक्ट्रिसिटी का आ रहा है, they need more current. So the wires that drive AC, refrigerator, geyser, micro, those wires should be such that they should be able to feed that much current to them. They are hungry for current. So the wires cannot have any resistivity. You want very obedient wires for them, thick wires. And that's why you see the sockets also, all those sockets will be mota mota, thick thick. Whereas if you see Diwali decoration, Christmas decoration lights, they are not that current intensive. उनको उतना नहीं चाहिए. But a thick wire, when you buy a thick wire, you are also spending from your pocket. A thick wire costs you much more because there's more amount of copper present in it. Is this thing now understood? Thick wires, so whenever, that's why do not try to power on a refrigerator. Refrigerator का wire छोटा गिर गया ना, this is where you and an electrician's difference will come. An electrician is only happy when the light glows. How the light is glowing, he is not happy on that. It's just like the father with a child and that ringmaster with a artist. The ringmaster in a circus is happy as long as the child is performing. Child के पाँव में पेन है, उससे ringmaster को कोई मतलब नहीं. But the father will never be like that. Father will say, ठीक है बेटा, आज छोड़ दो, कल फिर से practice करेंगे. You know that if you are extending the wire of that refrigerator and you have compromised on the wire quality, that refrigerator will run, but don't be happy. That wire will has more resistance. More resistance means वो wire heat up होना शुरू हो जाएगा. Because it wants current. So it wants the electrons to go. Resistance means the electrons cannot go. A lot of bombarding will happen and heat up होना शुरू होगा. Is resistivity का concept clear हुआ? So if you actually make the area half, so another type of problem they may give you is, let's see one more type of problem. ये समझ में आया आपको? एक और सिनारियो देखते हैं, चलो. Let's see one more scenario. The next scenario is, let's say this is my wire, and now what our friend Shaurya does is, इसको bend करके half करता है, इसको bend करके half कर देता है, ठीक है? So the wire will be something like this. ऐसे bend करके half कर दिया, which I can now think as, this is same as L कितना हो गया? L by 2. A कितना हो गया? 2A हो गया. The cross sectional area just becomes double. You have taken the same wire and you have folded it. So what about the length? The length has become L by 2. What about the cross sectional area? The cross sectional area has become doubled. So let's check its resistance now. What is R1 equal to? Rho L upon A. What is R2 equal to? Rho L की जगह क्या लिखेंगे बेटा? L by 2, right? And A की जगह क्या लिखेंगे? 2A. जरा इसको ठीक करते हैं. Rho L divided by 2. This is again divided by 2A. So into 1 by 2A, which is equal to 1 by 4 rho L by A, which is equal to 1/4 of R1. आपने मोटा बनाया ना एंड ऑफ द डे, तो इसकी रेजिस्टेंस फॉल करनी चाहिए भाई. मोटा बनाया आपने, मोटा करते ही रेजिस्टेंस फॉल कर जाएगा. आपने सीखा ना, जितना मोटा वायर उतना भारी भारी चीज चला सकता है ये. The wires which are coming to Argentum block are feeding how many houses? So many, 120 flats. वो वायर का मोटा पा देगा, यो मोटे मोटे वायर आ रहे हैं, मोटा बनाया आपने. So your resistance has become 1/4 now. Your resistance has become 1/4. ये सारे क्वेश्चंस आते हैं. पहले जो दो आपको ऑप्शंस दिखाया ना, those are there in your book. एग्जाम में आपको प्री बोर्ड में ऐसे पूछेंगे. A wire is taken and bent and made half. Bent and made half means you have just made the cross section twice. Got it? So this is a practical application. Sometimes say suppose I am falling short of this much of wire. This much of wire. नहीं है मेरे पास. I can't go to the market. But I have some पतला wire which is quite lying idle with me. बड़ा है. तो कैसे यूज करें? उस पतला वायर को छीलो, हाफ करो और मोटा बनाओ. काम आराम से करेगा. आराम से काम करेगा. ठीक है. Let's see one more criteria. Now our friend, what he wants to do, he is elongating it such that length has become 2L. Length has become 2L. Length is 2L, but area has become half of the previous one. पतला कर दिया उसको. आटा आटा, have you seen while making roti you make that आटा ना, खींच दो उसको, so it will become patla. So what he has done, he has extruded this wire in such a way that the cross sectional area has become half of what it was, but the length has become twice. So let's evaluate what is R1. R1 will be equal to rho L upon A, no change on it. R2 becomes equal to rho L has become how much beta? 2L, and A has become how much? Half A. So this is equal to rho. So we have a 2 rho L divided by A by 2, means into 2 by A, into 2 by A. So it has become 4 rho L by A, which is, sorry, 4 rho L by A. So 4 times of R1. आपकी रेजिस्टेंस 4 गुना बढ़ गई है. अभी आपने पतला कर दिया ना वायर को. So this will not allow current to go. अरे current is like one man. टनल पहले बड़ा था, आपने छोटा कर दिया. आदमी जाए तो कैसे जाए? नहीं जा सकता है ना. लेकिन आप चाहोगे फिर भी जाए, तो आप क्या करोगे? यहां से और जोर से लात मारोगे. जाओ. And how do you give that lath? That lath you will be getting by increasing the voltage. See, understand. A man wants to go through here. He is easily able to go through. Now you have reduced the tunnel size, right? But you are a illiterate, miser, household guy. So you want that man still to go through here. आप डांटोगे, ठपकारोगे, मारोगे उसको. So what you will do? You are jacking up the voltage. वो आदमी जैसे ही जाएगा, ये फटेगा नहीं. बस यही होता है. जब आप सस्ते पतले वायर से एसी को वायर करते हैं और रात को सोते हैं, तब आप उठते हो, आई स्मेल समथिंग बर्निंग, ये वायर जलना शुरू हो गया है और इसी से आग लगता है. Human beings have a very bad taste. They will spend anything on interiors. When it comes to electricity, everyone will say, यार बहुत खर्चा हो गया, 5 लाख चले गए इंटीरियर में. इलेक्ट्रिसिटी पे कोई भी spend, people find that they are basic. And in India, we usually do not have the habit of spending for safety, because the safety is a investment which will never come in your use. Like you have put a very high costly safety item. It will come into use if there is a calamity. But if there is a calamity whose chance is 1 out of 100, that day you will be saved. Our mentality is like that. We can spend thousands on a wine and whiskey, but when it's to buy a mineral water, a regular water, too expensive. We don't spend on that. Mineral water हमें expensive लगता है, but दारू expensive नहीं लगता है. तो ये हमारी mentality है. तो electricity के साथ, electricity becomes your enemy only when you are not treating it properly. ये चीज समझ में आया आपको resistivity? Now, can I adopt this? So use this funda to solve any problem related to resistivity and resistance. And these problems will be a wire is bent, a wire is made half and all. Okay. Next thing. Now, do you know what is alloys? Alloys. Alloys are what? Homogeneous mixture. After mixing two particular metals in any proportion that you may desire, your proportion is to your desire. Alloy is not a compound. Alloy is a mixture. Mixture means I can mix it to any proportion. One of the famous alloys like brass, bronze. Bronze is copper and tin. Brass is what? Brass is copper and zinc. So we have found, research shows that if you take an element E1, it can give you a resistance, say R1, and element E2 gives you a resistance which is, say, R2. But if you make an alloy of E1 plus E2, maybe of some variations, then you get some resistance R which is much high as compared to, say, R1 plus R2. मतलब R1 का एक, you take an element E1 and you take a standard wire. Same specs you take E2 and make a wire. And same specs you make E1 and E2, you make an alloy. You make an alloy and you start making a wire of the same spec. In this case, you will find the resistance is not R1 plus R2. If you even mix it to the same proportion, is significantly higher than R1, R2. And this property is used a lot in making heating elements. All the heating elements that you have, toasters, geysers, soldering irons, ovens, वो गर्म कैसे होते हैं? We have got heating elements. The heating elements will be something like this. This is a heating element, okay, or the immersion rod. We show it a heating element. So we will be connecting this to the electricity source. The current will start go here, and this is a resistance which is very high. The current is unable to come back. यहीं पे जाके फंसना शुरू हो जाता है उसको. And lot of electron fight will happen. As a result, this starts becoming red. This is the same funda that we use to make what is called our electric iron. We will study this later in this chapter also. These are known as heating element. So one such alloy is known as nichrome. As the name suggests, nichrome comes from Ni, from nickel, and chrome comes from chromium. Nickel और chromium का alloy है, ऐसे Constantan alloy है, Magnanen alloy है. Nichrome is the alloy which is present in all heating elements like your electric iron, toasters, geysers के heating element. It's all nichrome. So, and the electric bulb that Edison had made, उसके अंदर भी तो ऐसा ही कुछ है ना. So there we have got a substance known as tungsten. Tungsten इतना बेहतरीन चीज है that when you pass high voltage through it, tungsten offers resistance, and in this resistance, tungsten gets heated up, and when it gets heated up, it starts to glow, but it does not burn off. It does not burn off. So that oxidation does not happen, you have punched inside what? Nitrogen or argon. Argon होने से bulb will be very costly, nitrogen is sponged. That's why whenever you take a glass bulb, tungsten, TUN, tungsten is the element, tungsten, its symbol is W. Tungsten is the element with which filaments of bulbs are made. Incandescent bulb. इस bulb को fuse होने के बाद just drop it on the ground, it will always make a blasting sound, pop करके, because the trapped nitrogen gets out. ठीक है? In our childhood days, we used to be hungry for these fuse bulbs during kite flying. For what? Making manja. अभी जैसे आप मांझा वायर्स ले आते हो, हम लोग बड़े ऑर्गेनिक बच्चे थे. How we used to make manja? Bring all bulbs, medicine bottles, tube lights, and then take one crusher and crush it, making fine powder of glass. And then take some glue. Either it can be Fevicol or rice starch and something, and then you make a broth of it and make it as gaढ़ा as possible. And then on a field, there will be guys who will be putting some dandas, and the threads will be all in like puja darshan, and you will take that glue in your paper and you will go on, whole day this is the task. By the evening the glue will dry, and then that becomes manja, very organic manja. Okay, chalo. Yeah, sure. Okay, now some real life examples. We have understood a lot about resistance, a lot about resistivity. The next topic is combination of resistance, but before that, let's understand how to use these concepts. So what is resistance? Resistance is the property of any substance by which it opposes the flow of electrons. Resistance job is to stop the flow of current. Current jana nahi chahiye. It should not go. It should not go. But if the current still wants to go, the only option left to you is jack up the voltage. Pump it up more. Go, beta, go. But there is a limit to which you can jack up. Let's use this knowledge on real life examples. ठीक है? चलें देखते हैं कैसे real life examples. Now only we'll understand. Okay. अब बड़े मजेदार examples आएंगे आप. So let's say all of you must have seen an LED bulb. Okay. I'm doing real life examples. This is a LED which is available in the market. Cost around say 50 paise to 1 rupee. LED ऐसा रहता है, ठीक है? LED is unidirectional ना, इसको जैसे connect करो नहीं चलेगा. The longer one is always the positive one, okay? Shorter one is the negative. So how do you glue an LED? An LED always needs a power source which should be 3 volt. If you give anything more than 3 volt, साथ साथ जल जाएगा. 3 volt से कम में जलेगा पर ग्लो नहीं करेगा. 3 volt is the best. Like when you switch on a TV and all that red light comes on a set-top box, they all run on 3 volt. So 3 volt कैसे करेंगे? बाजार में in the market, the type of cells that we have the Duracells. So Duracell, each Duracell is 1.5 volt. So this should come to the positive, right? Because it's, so positive is always this side. So this is positive, negative. So this is 1.5 volt, and then one more 1.5 volt. We have connected them in series, and we connected here. This is positive, this is negative. So how much are you punching? 3 volt, 3 volt दे रहे हो. LED खुशी खुशी जलेगा. When an LED glows, obviously a current is flowing through the circuit. This current is measured to be of 25 milliamps. Means 25 into 10 to the power minus 3 ampere. This much data you have, and these are real proven data. There's nothing wrong about it. And every LED will consume how much current? 25 milliamps. LEDs consume quite a lot of current. 25 each one LED, right? 3 volt. Now this is our new project and fun of से श्रेयस का नया project यही है. LED खरीद के लेके आया है, बैटरी लगाता है और सारा दिन ऐसे जला रहा है. ऐसे जलाते जलाते बैटरी तो खत्म हो जाएगा, right? Now from here my childhood stories start actually. In हमारे जमाने में उतना LEDs नहीं, we used to have torch bulb or something, ठीक है? तो torch के bulb जलाते थे. Then this particular 1.5 volt cells will one day give off. Don't you agree? Will give off. So bulb will no more grow, and you become sad. So you will ask again your parents, पैसा दो, battery लाना है. But we were not so blessed. next battery no one will fund you, then they will say okay, score good in tests and other things. So necessity is the mother of invention. Yes, so let's put some practice now. Chalo. So you have all these, what you call, Tata Sky, ये सब आपके घर पे. Now many people have switched on to, so what you known as internet-based television system. Okay, you have your internet. You're using the internet cable directly to view. So your Tata Sky set-top box is now lying idle. So the Tata Sky set-top box has got an adapter. ऐसा एक black color का adapter रहता है ना? Have you seen or not? Means there will be the pins of this adapter. और यहाँ पे कैसा रहेगा? A small jack will be there. This Tata Sky adapter can connect to the wall outlet and pull in 240 volts AC. AC voltage is always available to us. And in the output, say this is giving me 9 volt DC. Direct current, 9 volt DC. और हमारा ये चलता है 3.4 volt DC में. ठीक है? Now my parents will no more fund me again with 2 more cells. खत्म हो गया. This is lying idle. अब सवाल आता है, इससे इसको जला सकते हैं कि नहीं? कितना दे रहा है आपको? 9 वोल्ट दे रहा है. मैंने स्टार्टिंग में ही आपको कहा था, एलईडी को अगर 3 वोल्ट से थोड़ा भी ज्यादा देंगे तो फटाक फ्यूज हो जाएगा. देन प्रॉब्लम इज डबल. ऑलरेडी पेरेंट्स आर नॉट फाइनेंसिंग बैटरी. नाउ बल्ब आल्सो गॉन. हाउ डू वी ग्लो इट नाउ? बल्ब नहीं, 2 बल्ब है ना, इसी को एक ही को जलाना है भाई. 2 बल्ब क्या, 2 बल्ब होता तो ये खरीद के नहीं देता. इसको जलाना है. समथिंग लाइक दिस फेलो कैन ईट 3 रोटीज. दिस फेलो सेज मैं 9 रोटी देता हूं आपको. नाउ यूज योर कॉमन सेंस. व्हाट शुड यू डू? दिस फेलो कैन ईट हाउ मेनी रोटीज? 3. हाउ मच इज दिस गिविंग यू? 9 रोटीज. व्हाट इज द मिसमैच? Too much. Somebody said something online.
6 का mismatch.
6 रोटी ज्यादा दे रहा है. 6 रोटी को क्या करोगे? Use your head.
Give to someone else.
ऐसा बोलने से इस प्रॉब्लम में कैसे करें? This is what students don't understand. That's why I always say in my videos. People solve all calculations. ये तो रियल लाइफ है. ये इलेक्ट्रिशियन कर देगा आपको. इलेक्ट्रिशियन मतलब the boys who do not study well, but they'll be आज friends हमारे YouTube वीडियो में हम इसको इससे जला के दिखाएंगे. So you should say who has more real life knowledge. Now you studied it. You have studied all the concepts for this. You are not just applying your head. Yeah, what is more here? What is more here? What is the parameter which is more? Voltage is more. 3. Always remember the whole chapter is about Amar Akbar Antony. Voltage, current, resistance. What is more here?
Voltage.
Voltage. If voltage is more, then what does Ohm tell us? Voltage increases. Potential and voltage are same things. If voltage increases, what is Ohm's law? How does Ohm's law start? Current flowing through a conductor is directly proportional to the voltage. पढ़ते ही नहीं हो ना, इसलिए तुम्हें मजा नहीं आता है. Current flowing through a conductor is directly proportional to the voltage. You are giving more voltage. So what will happen? Current flow will be more. हमें नहीं चाहिए ना वही. तो किसको घुसाना पड़ेगा बीच में? Resistance. We need a resistance who should come in between. Who will stop this excess? Now how to calculate that resistance? जलाना है. ये देखो, ये तुम्हारा प्रॉब्लम नहीं है, सब बच्चों का यही प्रॉब्लम है. Real life knowledge is 0. We need a resistance to save this bulb. So what we are doing now? We are getting feed from our Tata Sky adapter. How much is the feed? 9 volt is the feed which is coming, right? And we want to connect it to our LED. हम उसको हमारे LED में कनेक्ट करना चाहते हैं. LED को कितना चाहिए? 3 volts चाहिए. इससे ज्यादा दे दोगे तो LED पट्टू. So we need to connect something in between. तो आपने क्या बोला? आप यहाँ पे एक रेजिस्टर कनेक्ट कर दोगे. The resistor will limit the excess current or voltage, whatever it is, and feed exactly 3 volts to it. Now how to find this resistor? बाजार में जाके तो खरीदना होगा ना. So what is the rating? We will ask. भाई साहब रेजिस्टेंस दीजिए. क्या रेजिस्टेंस? What resistance? Sir, I don't know. I am a student. 6 volts का रेजिस्टेंस नहीं होता है. Resistance in the market is sold in ohms. How many ohms resistor do you want? The shopkeeper तो तुम्हारा बेइज्जती करेगा. कितना आप जाके पूछ के आइए जाइए. So let's see this. What is the excess? What is the potential drop you want 3 volts, you are getting how much? 9 volts. So how much of drop do you want? 6 volts should be dropped. Current in the circuit is how much? 25 milliamps. So let's do V upon I is equal to R, right? What is the V? 6 volts you want to drop. What is the current? 25 milliamp. 25 into 10 to the power minus 3, or it is equal to 6 by 0.025. ठीक है? Anyone has a calculator? इसको calculate करो, कितना होता है? 6 divided by 0.025. How much has it come? 320 के आसपास आएगा.
6 divided by 0.
On 0 to 5. 240. So we are getting a resistance of how much? 240 ohms. Right? This is पक्का हिसाब. But हम लोग क्या बोलेंगे? Right? Sometimes what happens? It is windy outside. 1 minute. Hello? Ish. Double 9 7 888. Oh yeah. Okay. So we need 240 ohms. Now this is our calculated data. It's breezy outside. A wind cheater is sufficient to make you get comfortable. But what do parents say? Hey, कार्डिगन डाल के जाओ, ज्यादा हवा है. तो हम फैक्टर ऑफ सेफ्टी लेते हैं ना, तो थोड़ा फैक्टर ऑफ सेफ्टी बिल्डअप कर दो. मार्केट में जाके हम क्या कहते हैं? 300 ले लो, थोड़ा सा सेफ्टी बिल्डअप कर लो. एंड यू गो टू द शॉप एंड यू से 300 का रेजिस्टेंस दीजिए, 300 ohms. There also data is insufficient, but this is where pleasure comes. जैसे ही आप 300 ohms का रेजिस्टर कनेक्ट करोगे ना, this LED will glow up happily, क्योंकि इसको कितना जा रहा है? 3 volts जा रहा है. अभी कैलकुलेशन मैच हो गया है. But कुछ तो लफड़ा होएगा. What is the लफड़ा? Something गड़बड़ तो will still happen. It is like the king is inside the fort and a heavy army is now attacking his fort and the doors are held by the army. What is going to happen? This is a fierce army fighting to get inside. King is happy. क्या होने वाला है थोड़ी देर बाद? After some time. After some time, where is the pressure going to fall on? कभी ना कभी तो he has to be very good. ये resistor गर्म होना शुरू हो जाएगा. Because it is stopping that much of current ना. So the next thing the shopkeeper will ask you, how many watts do you want the resistor? The resistor will get heated up. So heat is an energy. So that we will start learn in our power section, that when you get heated up, then this resistor, based on the amount of time you are running, this will consume some power. That rated resistor you have to put. Like 300 ohms resistor in the market can be available at quarter watt, half watt, 1 watt, 15 watt. ये मोटा हो जाएगा. All of 300 ohms. Same weight था. बच्चा, बड़ा, बाहुबली. With one sword only they are fighting. But if the heat is too much out here, you need a resistor which can tolerate that heat also. वरना जैसे ही आप यहाँ पे resistor लगाओगे, कुछ देर तक ये जलेगा, ये कुछ नहीं होगा. यहाँ पे देखना लाल होके ये चटक करके फट जाएगा. Because he's blocking 9 volts for you, not 9, 6 volts for you. We have to first calculate how much of power is dissipated here, heat. And what is power? Energy upon time. That's your next section of study. Once you calculate that the power here is say P watts, then again be the mother. Don't buy P watts resistor. Buy something like 2P. Hyderabad doesn't get cold. A wind cheater is ye le lo na, nahi pehenna to haath mein le lena. We always want over design. Indians are famous for over design. We designed a car called Ambassador. Pura aadmi andar mar sakta hai, but the car will never over topple. That's why huge metals were used. Look at the buses of Bombay and all best. 44 sitting, 22 standees. Means we have already counted that 22 people will stand. How many people stand? Much more than that. So the buses are designed over. हम लोग हमेशा over design करते हैं. So if P is the power of this particular resistor, the heat that is coming up or the power that is consumed, we'll buy a resistor of 300 ohms of 2P. Double कर लेंगे. In that case, आराम से. So you switch it on in the morning, शाम को आके भी छुओगे ना, कुछ गर्म नहीं हुआ, because it has the ability to dissipate that much of heat. Every electrical device, when you are starting, like say a set-top box or something, have you seen they all become warm? I'll not say hot, warm.
Yeah.
Why? Because they are dissipating energy. Heat is being dissipated. And if you turn the backside of set-top boxes, they are just metal. They're just metal. That metal is known as a heat sink. What is a kitchen sink? A kitchen sink is where you drain down all your water. A heat sink is where you drain down all your heat. Heat sinks are must. Bike dekha hai? In the bike, you see that engine section. Have you seen that fin, that part which cut off, which is most difficult to clean with a toothbrush? That itself is the heat sink. A bike develops a lot of heat. How are you cooling the bike? Bike is cooled by air. It's an air-cooled engine. The more you ride the bike, the more the air will be cooling it. How do you cool a car? Car has got a coolant. Car cannot be cooled by air. So the car has got a fluid called coolant, which is there in the radiator of the car. So bike gets cooled by air. So सबको cooling होना पड़ेगा. इसलिए सब devices में heat sink रहेगा. You open up any device, you will find a big metallic plate. That is the heat sink. The heat has to go out, because if the heat starts getting locked, ये थोड़ी देर के बाद जलना शुरू हो जाएगा. Understood? That's why when your mobile is absolutely drained, at that time, whenever you connect your mobile, the charger becomes very hot. Huge current is being drawn by the mobile to initially get charged. And once the mobile gets completely charged, it says, charger, I don't need you. So once it has become 100%, you just go and touch the charger after some time. Thanda ho gaya pura. Same thing happens with your laptop. Second, ye samajh mein aaya? So you can actually use these to do any type of jobs that you want. Okay, next, another type of example. Let's see one common example. Okay. Let's take a ceiling fan. Let's take a ceiling fan. And let's take your mobile. A mobile में जो आप charger लगा रहे हो ना, this charger is set 2 ampere charger. Means when the mobile is absolutely hungry, at that time the maximum current it will draw from the charger is 2 amperes, right? And this is a ceiling fan. If you do the calculation, a ceiling fan draws current when it is fully running. If you exactly want to do the calculation, then the calculation would be something like how much current does a ceiling fan take? Okay, so 65 watts divided by 230. So it's this much, 0.2, and divided by 0.8, 0.4. Some 0.4 ampere current it is pulling. 0.3, less than this. Okay. Now this is the wire which is coming to the ceiling fan, and this is the wire which is going to the mobile. A mobile is absolutely discharged. So the mobile is right now in a mode like that, it is consuming current. थोड़ा सा blade से I start exposing the wire part of it. I have exposed the wire part of it, and इसको भी blade से wire part को expose कर दिया. ठीक है? And I bring you, and your feet is naked. Naked feet में खड़ा कर देते हैं. Do you have the guts to touch this wire? No. This is mobile charger currently turned on. This is mobile charger currently turned on. Is my feet naked?
Yeah.
This is 3 ampere charger. You asked me to do the same thing with ceiling fan?
Yes.
शौक नहीं, तुम हो गया तुम्हारा. All your last wishes you take and then go and touch this. पर problem क्या है? आप 2 ampere छू रहे हो, कुछ शौक नहीं हो रहा. Now you can say that, sir, this is not charging. Let us charge the mobile and just touch this with our hand, right? और इसको छू लेते हैं. इसको छूते ही मर जाओगे. But I am guaranteeing you the current flowing is 0.4 ampere through the wire. The current flowing is 2 ampere through the wire. Why? What is the problem? More at a time? Current is current. Current means it has taken the time factor with it. Can you guess what is where is the calculation going garbar? ये answer चाहिए. This is what when I go in interviews na, that HR guy will always used to tell me, now you'll start boring this fellow. I said, मैं तो एक ही सवाल पूछता हूँ, ये क्यों हो रहा है? सब कुछ करेक्ट है, आपका अंडरस्टैंडिंग में रॉन्ग है कहीं. मोर एनर्जी से कुछ नहीं लेना देना. इसको 0.4 एम्पियर जा रहा है इस वक्त, यहां से 2 एम्पियर. आई कैन पुट एन एमीटर इन बोथ केसेस एंड शो यू. आई एम आस्किंग यू टू टच दिस विथ योर लेग and touch this naked. This one, if you touch, I won't be able to ask you the next question because you're no more there on earth. This one you'll be able to answer. आप लोग एक चीज गौर नहीं कर रहे हो. The output of this, any mobile charger, the output is 5.1 volt. And the voltage that is running here is 230 volts. Do you understand? बहुत ज्यादा है. Now start understanding here. So you have put your hand. This is your hand. ये आपका हाथ है. The human hand. Let's say this is looking like a frog's hand, but you say this is a human hand. The human hand can also be compared as a resistance, है ना? हर चीज का तो resistance है. तो human flesh का भी resistance होगा. From here it is proved that 0.4 ampere current is enough to kill me. In fact, 0.8 एम्पियर में डेथ इज गारंटीड. you'll die. एंड एसी जब चलता है, हाउ मच इज एन एसी पुलिंग? 8 एम्पियर्स. मतलब एसी को अगर हाथ लग गया ना तो गॉन, यू आर फ्राइड. 0.8 to 1 एम्पियर इज सफिशिएंट टू किल यू. सो दिस इज 0.4 एम्पियर. मींस इफ यू आर नॉट वेल बिल्ट एंड ऑल, इसमें भी आप मर जाओगे. नो क्वेश्चंस आस्क्ड. सो द क्वेश्चन अराइजेस that one thing is for certain, we have understood that sir 0.8 ampere can kill human being. Is this understood or not? This we have understood. But you are going to say, sir, but here 2.2 ampere is not killing me. Here you are saying 0.4 ampere will kill me. I have said 0.8 ampere will kill you. No doubt about that. It will kill you. That means when 0.8 ampere passes through the human being's hand, 0.8 ampere passes through the human being's hand, it is sufficient to cause fatal results in him. You are again not applying the knowledge of resistance. Let us understand 0.8 ampere is a person. Current is a person. This is what? Resistance. Resistance always chokes the conductor. And this is 0.8 ampere. 0.8 ampere wants to pass through the human hands. Then you need some amount of kick. ऐसे तो जाएगा नहीं. 5.1 volt as a kick is not sufficient to drive 2 ampere through the human flesh. When you talk about the mobile's resistance is much low. Overall, the mobile is a resistance. Overall, it's a resistance, right? ये जो resistance है, it is such that when you give a kick of 5.1 volt, it's a big tunnel. 5.1 volt देते ही 2 ampere happily गुजर जाता है इससे. You are not like that. You are a body whose initial resistance is much more than the mobile. So 5.1 volt as a kick is not sufficient to pass 2 amperes through you. आपकी मौत तो 0.8 में ही हो जाती है. 2 एम्पियर अगर गया तो आप मरोगे ही. और आप 2 एम्पियर को 5.1 वोल्ट से लेने की कोशिश कर रहे हो, नहीं जाएगा. But if we increase the kick, that is, we jack up the kick to something like 230 volt, we are kicking you with 230 volt, then we don't need even 2 ampere. A 0.1 ampere will pass through your body, sufficient to fry you. So question now arises, do you die by voltage or do you die by current? करंट से मरोगे. वोल्टेज से कोई लेना देना नहीं है. उल्टा तरह से सोचो. कोई कहता है सर हाई वोल्टेज में मरते हैं, बात सही है, पर आंसर अलग है. करंट, हम 0.8 के करंट से मर जाएंगे. अगर वोल्टेज इज इनफ टू मेक 0.8 pass through our body, we will die. If the voltage is not enough to make 0.8 pass through our body, we won't die. We won't die. We will not die at all. These calculations will come more in near future. आगे पढ़ेंगे जब. When you studying power, we'll give you some more such examples. So if somebody tells you that आप mobile के charger को छू रहे हो, sir, we are able to touch it. You are able to touch it and you are smiling here because 2 ampere is going inside this mobile, but आपके body में some 0.000000 some ampere is going because your body's resistance is much more than the mobile. So sir, means 2 ampere can never enter our body. Yes, if the kick is sufficiently strong. 5.1 पे क्यों खेल रहे हो? जाओ ना 230 पे खेलो, तब तो 0.8 पे तुम मर जाओगे. So what is your fatal current? 0.8 to 1 ampere is sufficient as a fatal current to you. Are you understanding? And there is a protection device in your house. All our flats in Pebble City have that, which we call as RCCB, Residual Circuit Current Breaker. Cost of this product as on Amazon right now is around 3,500. This is cheap. ये लोग लगाते नहीं हैं. Costly. This will not even allow 500 milliampere current to pass through your body. And once there is a little bit of a short circuit, it will immediately trip. So ideally in Pebble City, you should not get a shock. If you have got a shock, then there's some fault in the wiring in your house. So stop spreading rumors inside the flat. I'm saying inside the flat. So जैसे आप छुओगे, immediately that will trip. Immediately. And in next class, I'll bring my test lamp and I'll show you tripping the house. We will do it and we'll trip it. Trip karega. We'll pass it through the earth, not through my body. We'll pass it through the earth. But for that, we have to first learn earth and then we will do it. Otherwise, the experiment that I do, you will not get any pleasure seeing that. But it will trip. And if it doesn't trip, time to replace this device. That's why this device should be frequently tested. लगा तो है, चौकीदार है आपके हाउसिंग सोसाइटी में है. कभी देखा रात को जागा रहता है, all is well, बस you are happy with that. Have you ever tested your RCCB trips or not? So you should do some force tripping on it. But we are happy only writing WhatsApp messages. Guys, this. So when this child episode happened, as I always say, so there was supposed to be this tower WhatsApp and fear mongering going on. So people were saying this is that, this, that, people, there's no protection device and all. I said, so many Diwali lights you hang on that particular balcony wire. And how do you see the evening of Diwali? You put your hands on the balcony and you say, wow, their flat is looking so beautiful. उनका कितना अच्छा लग रहा है. आपको कभी fear होता है कि वहां से भी तो electricity, that's an iron grill. If electricity leaks, do you earth that particular thing? You don't do. Or you are not understanding because you have not read that section. That whole grill can become electrified. But you put your hands on the electric grill like this, you, your children and all, you see all the flats. Then somebody in the tower wrote to me in Argentum group. Right now we are discussing death due to what has happened in the playground. That was the day I got myself out of this tower WhatsApp group. Because the people feel that death can only happen in that outside ground. यहाँ में नहीं हो सकता है. Your knowledge is so poor that you don't know where you should be. You only know how to pass on fear and fear things. तो balcony में भी तो आप मर सकते हो ना. आपको किस प्लेग्राउंड में मौत होगा क्या आपका? Not that. That's an unfortunate incident. No doubt about that. But what is the learning from that? You crib on that, or do you make sure that you're foolproof? You're foolproof. You don't understand this device. This is such a beautiful device that all the companies have made. This can protect your house, life. It protects life. Many people will say MCB did not trip. MCB is not to save a human being. MCB will save the appliance, the TV, not you. If you want to speed high, you need an RCCB. Cost is how much? 3,500. Ask somebody to put it who is not in a flat and all, independent house. And suppose you go to his house and say there is no RCCB, and you say RCCB एक लगाइए ना, कितना है? Oh, चलता है, नहीं चाहिए, बहुत expense हो गया, sofas and all costed me. The next class we will do combination of resistances, where we combine resistances, and we have more interesting things to share there. That will conclude another part of the chapter. Then power, and that concludes electricity for us. So please study this and come up to resistivity. You should be fine when you come in the next class. Okay, chalo.